It's opening. So on number 7, we have to number 7E. What is the probability of a randomly selected particle that has a speed of between 1500 and 2500? How did you calculate that?
Which
In like the preparation assignment that we do?
Yeah, what number was it again?
Number 7 and part E.
Okay. So I use the applet the whole time. There's a link to, it's called the normal probability applet.
Right.
That.
Right. Normally you just have one number though, and you can subtract 1800 and then you divide it by the 600. So what do you do when you have two numbers?
So what I did was I took what I got for C, which was a probability that's less than 2500.
Uh-huh.
And then I subtracted the probability of it being less than 1500.
Oh, gotcha.
And then that way you.
Okay, yeah, that makes sense. Thank you.
I checked the answer, and that's what they got. So
that makes sense. That was my only question on that. Thanks, guys.
Cool. Okay. Everyone have your Quizlets?
Yeah, I'm gonna hurry and open up that applet before we start.
Good idea.
Okay. Is it my turn to start?
Sure. Yeah.
Okay. It doesn't look like there's really a story. First question is question 3. The total area under a normal distribution curve must equal, and the answer is 1, right?
Yeah.
You want to go, Dalen?
Sure. Yeah, I got it. Under certain circumstances, a normal distribution curve can drop below the x-axis. I think that's false.
I believe so.
I think so too. Okay. All right. A normal distribution curve is symmetric. Sorry. Normal distribution curve is symmetric, and that's true.
Mm-hmm. Alrighty. Which of the following elements of the figure represents the z-score? And we've got C.
Yep.
Yeah.
Okay. Which of the following elements of the figure represents the probability that the z-score will be greater than 1? Is it B?
I think so.
I'm guessing 1 would be the z-score, is what they're saying. Yeah, the z-score.
Yeah, so everything greater than that would be the area above it, where B is.
Right.
I agree.
Okay.
All right. According to the 68-95-99.7 rule, what percentage of the data from the bell-shaped distribution will be within one standard deviation of the mean? Write your number percentage, such as 42. Okay, so it's going to be 68.
Yep.
Why did you answer the question?
As long as you read it, you should have got that one.
Yeah.
Yeah. That's true.
Okay, so suppose the z-scores come from a standard normal distribution. Using the normal probability applet to answer this question, what proportion of z-scores will be between -1 and 1? And that would be 100%, right?
No.
68, right?
68.27.
Between 1 and 1. Am I looking at? Oh, yeah. You're right. So
0.827.
0.6827.
So it says
Oh.
if the answer was 0.389184, so it's to the 3 decimal places.
Oh, yeah, you're right.
So it'd be
683.
0.683, yeah.
Okay.
Yeah.
Cool.
Wait, how did you guys get 0.683?
So if we went to that tool
Right.
and then we unclicked the sides and clicked the middle and just saw what's between the two ones.
Okay, I gotcha.
My turn?
Yep.
All right. Same question, only what proportion of the z-scores will be between -2 and 2? And that'll be, it would be 95. Let's see. 99.955.
That's what I got.
That's what I got.
Gotcha.
Okay. Suppose that the z-scores from a standard normal distribution. What proportion of the z-scores will be between -3 and 3? So I got 0.997.
Yep, me too.
I agree. Look carefully at your answers to the last 3 questions. What do you observe? The values match the 68, 95, 99.7 rule. I think so. As the z-score increases, the area between -z and z decreases, which is false. The probabilities double as you move from z1 to z2, and that's also false. So I would say it's A.
Yeah.
I agree.
Yep.
True.
Okay. The amount of protein that an individual must consume is different for every person. There are solid theoretical ideas that suggest that the protein requirement will be normally distributed in the population of the United States. The protein requirement is given in terms of the number of grams of good quality protein that must be consumed each day per kilogram body of weight. The population mean protein requirement for adults is 0.65, such and such, and the population standard deviation is 0.07. What proportion of the population have a protein requirement that is less than 0.60?
This is where we find the z-score, right?
Yep.
And then type it into the thing.
Yeah.
Yeah. Okay, so the z-score I got was 0.714.
That's what I got.
Mm-hmm.
Okay. And they want to know how much, let's see, the proportion is less than 0.60. So that would be 0.2376?
Yeah.
Yeah.
So I think they want it in. Well, at the beginning it says 3 decimal places.
Okay, so
0.238.
238.
So which one, let's see, which area are you looking at?
So I got a negative number, negative 0.714, right?
Yep.
Yeah.
That
Or you-
is right where that red line is. So everything before that is less than.
So how come it wouldn't be the other z-score?
Because if it was a positive number, you could have done the other z-score and everything before it. But when you
Okay.
do the-
So because I put in the calculator and so it's already negative, so you know that we have to go from that one.
Yeah,
Yeah.
and you can kind of tell because the value that we're looking up is less than the mean. And so the mean is 0.65, and so you know ours is already going to be less than average.
So your area will be less than it is at the mean.
the middle of it.
Yeah.
Okay. Okay. That makes sense.
Yeah.
I was looking at it a funny way because I was thinking 0.6 grams. So I was thinking the positive one is closer to 0.6 than the negative one, but that's wrong. So, okay, my turn.
Yep.
What proportion of the population has a protein requirement that is more than 0.6 grams? So this would be all of the space to the right of that same Z line, right?
Mhm.
So 0.762.
Yep.
Yep.
Is it my turn?
It's mine, yeah. Sorry.
Oh, you go ahead. Go ahead.
What proportion of the population have a protein requirement that is less than 0.7 grams? So I think that's the same as a couple of questions ago. We're trying to find the z-score first.
I think it's the same Z-score and it's positive.
Yeah, that's what it looks like to me, 0.714.
Yes. Bizarrely the same answer as the last question.
So,
And so the question was, so less than 0.7. So we would highlight the middle and the left and not the right.
mhm.
So I got 0.762.
That's what I got.
Me too.
Same.
Hey, this is the question I asked you just before we did this. Find the probability that a randomly selected person will have a protein requirement that is between 0.6 and 0.7. And remember to find the area between the two values. Shade the left of each z-score and you will calculate and then subtract the smaller area from the large area. Make sure your answer is positive. This is the probability that a randomly selected observation will lie between the two values. Give your answer as a decimal. So the first thing we need to do is we need to find
Seven.
the area left of the z-score. Okay, so what you were telling me before is I can subtract our answer that we just got, 0.762, and subtract out of it our 0.238.
Yep,
Is that true? Did I understand that right?
I think so. That's how I understand it.
You can also just go to the normal probability applet and just highlight the middle.
Will that give us 0.524?
And it gives you, well, 0.5248.
Okay.
So it would round it up to 0.525.
Because the z-score for 60 or for 0.6 is the negative one, and the z-score for 0.7 is the positive one. So really, you just grab the middle.
Do we want to try 0.524 or 525 then?
I think we want to do 0.528 or 5.2. What was it? 0.52.
So when we subtracted it, it was 524.
Right. I think we want to do 0.525 because it's, I don't know.
I think so, just because it's in that thing.
Yeah.
Okay. Find the 35th percentile for the protein requirement for adults. Round your answer to 3 decimal places. So I would just type 0.35 in there, right?
Into the area.
Into the area. And that
Let's see.
is so okay, wait. I had a hard time with this when I was doing it in the homework.
So that gives us a z-score of 0.454. And so then what we do is we solve
Yeah.
for x, because we know what the...
Oh, that's right. That's right. That's right. Okay, I remember
So
that.
then we that
So
z-score
it's,
of 0.454, and then you times it by, right, and then divide it,
No, you
You
times
times
by
it by the
the...
standard deviation of
and then
0.07.
add the mean. Right?
z equals sample minus mean over standard deviation. So
What's the standard deviation?
0.07.
Oh, that question, right. And then you add the mean. Okay. Which is 0.65. Okay.
So what'd you guys get?
I got 0.682.
That's what I got.
That's what I got.
yeah, me too.
Whew. That was hard. That was confusing.
Yeah, that was a real math problem.
All right, the 80th percentile. So this is basically the same thing, only you type in 0.8 up there. Z-score is 1.282. So I got 0.7.
That's what I got.
Yeah, me too.
Hey, don't submit it. I think we got number 17 wrong.
The last question?
No, number 17. I submitted it one early, so I missed number 18 and 17. I didn't mean to, but
Oh no.
17's wrong for sure.
So wait, we need 17.
17's wrong. We gotta figure something out.
Okay.
So was 16 the 525 then?
Yeah, I believe so. Can I go back?
If you got it, I guess if you only missed 17, then yeah, it would have to be 525.
I think I missed 17 and 18 on that. It won't let me go back and see it. I jumped back into it because I was like, oh shoot, I submitted it too early, but I missed the last two, so we missed 17.
Those ones are confusing.
Let's see.
Up the textbook real quick. Genes. And this is the, let's see, converting a z, no, calculating percentiles using normal distribution. Okay.
So weird. I keep getting the same answer on it, but I must be doing it wrong.
Maybe I was wrong. Maybe we did get it right. I don't know.
Let's see.
You set it up correctly.
Here, I'll try to submit mine and see what I get.
Before it.
Hmm. Yeah, 17 and 18 are wrong, it says.
Oh. Is that 85% on the quiz?
It's 90.
Take it. No. I don't get. I really don't get what we're missing.
I don't either. I don't understand.
I'm looking at the equation, and so, okay, it says click on the area. Okay, first we need to find the z-score that corresponds to the 90th percentile usability applet. Check. Click on the areas under the curve until only the areas left of the positive z-score are shaded blue. Type the desired area or percentile in the top box at the top of the graph, which we did. The z-score corresponding to this area will be displayed in the bottom right box. And then, so then you get that, and so you set it up with the z-score equal to, on the top, x minus mean divided by the sigma, with your standard deviation, which we did that.
Yeah.
And then you do, so then it would end up being so you end up having your z-score multiplied by the standard deviation
0.07.
plus the mean. That's what it says in the book.
Plus the
Yeah.
mean.
So for 17, it would be 0.454 times the standard deviation, 0.07, plus 0.65, which would be 0.682.
We did something different though. We did 0.61.
For
17 last time.
Chris, did you do that?
Oh, I don't know. I'm trying to figure out how to put my last.
I have the answer as 0.682.
That's what I have.
And did I put 0.682 or 0.681? I don't have my last quiz still here.
Well,
I have my answer. I wrote my answers down though, I think. Yeah, I got 0.682 is what I had.
That's what we had on 17 and we got it wrong, right?
yeah.
I don't know.
All right.
I guess we should just email him because we're doing it exactly according to the book.
Yeah, maybe I'll email him, or we can all email him or whatever. Because I don't understand. I've done these all 3 times now. I don't understand what I'm doing wrong.
Yeah.
All right. Well, I guess I'm going to submit mine like this. And then-
Real fast, can we go through the answers again so I can just type them in?
Oh yeah.
Yeah, someone do that for us.
Yeah.
Let's see.
Question
3.
3 is 1. Just 1. Question 4 is false.
Okay.
Question 5 is true. Question 6 is C. Question 7 is B. Question 8 is 68. Question 9 is 0.683. Question 10 is 0.955. Question 11 is 0.997. Question 12 is the first one. Question 13 is 0.238. Question 14 is 0.762. Question 15 is 0.762. Question 16 is 0.525.
35th percentile.
17 and 18 are anyone's guess.
Huh.
What was 16.5?
0.525.
And did you guys look it up in the book again?
Yeah, I just read through the whole book. We did it the way the book says.
Did you say that 14 and 15 were both 0.762?
Yes.
Yes.
Yeah.
And 17, when we submitted it, we submitted 0.682. I know.
Yeah.
Yeah.
It's gonna drive me nuts.
Yeah, seriously. I'm going crazy. Okay. I'm going to email him.
7.
Do you guys, is there
mean, we
anything
can-
else? we should
No, I
do?
think we should just put the answers that we got, and when we get it wrong, email him and, like you said, email him and see what he says.
Okay. Okie doke. Well,
Cool.
thanks, guys. I'll go ahead and post these.
I'm
Okay.
so glad we're done for the
I
whole
know.
week.
All in 40 minutes. I think that's pretty decent.
Cool.
Cool. Well, we'll see you
Same
guys
time
next week, right?
Yeah.
Okay. Still plan on 2 lessons on Tuesday?
Yeah, let's do it.
Cool. Thanks, guys.
All right. Take care, guys.
Thanks,
Bye.
guys. See
Bye.
ya.